This is going over the answers to the area and volume revisited handout. So hopefully this clears up some misconceptions you might have about the area and the volume and the setup and all that. To find area of B, you're just looking at the top curve minus the bottom curve. In this case, the top curve is going to be 6. The bottom curve is going to be 2 square root of x. So the area is just going to be the top minus the bottom. So it's going to be 6 minus 2 square root of x with respect to x. The limits of integration, it goes from 0 all the way to the x coordinate, which is 9. It's going to be the integral from 0 to 9. You punch this up on your calculator and you end up with 18 as your answer. Part B is asking to rotate B around the line x is equal to 6. So if I kind of redraw the region, here's y is equal to 6, and here is y is equal to 2 square root of x. X is equal to 9 is a vertical line. X is equal to 9, like that. So it's going to be with respect to y, because it's going around this way. So you're taking this shape and you're spinning it around with respect to y. Okay. So with respect to y means your rectangle starts around this line and it goes all the way across like this. This is the shaded part. So all this is going to be your empty space. So if I kind of redraw my sample rectangle, this is the empty space, this is the shaded region, this is line x is equal to 9. Since it's going to be with respect to y, you have to put this in terms of y. So if you divide both sides by 2, you end up with y over 2 is equal to square root of x. And then if you want to do the square root, you would square both sides. This would be y squared over 4. This over here on the very far left is the y-axis, so you can think of this as the line x is equal to 0. So then your washer, with respect to y, is going to be pi. The entire goes from 9 to 0, so it's going to be 9 squared minus the empty squared. The empty in this case starts at 9 and it goes to y squared over 4. So this is the empty piece. So it's going to be 9 minus y squared over 4 parentheses squared. Like I said, with respect to y, because it's going around the line y, x is equal to 9. The limit, it starts at 0 and it goes all the way to 6. So you look at the initial area, it starts at 0, it goes all the way to 6 on the y-axis. So it's going to go from 0 to 6. You punch this up on your graphing calculator and you end up with the volume being equal to 226.8 times pi. For part B, it's saying that you want to set up cross-sections that are perpendicular to the y-axis, and these cross-sections are squares. So one more time again, if I redraw the region in question, perpendicular to the y-axis, that means that your rectangles are popping up out of the page this way. So your squares, I should say, are perpendicular to the x-axis, y-axis. So they're going to be popping up, going this way. So it's going to be with respect to y again. The bottom base is just going to be the right curve minus the left curve. In this case, the right curve is y squared over 4. The curve on the left is just going to be the y-axis. So you can just think of the base as y squared over 4. And since it's a square, it's going to be the same as the base. So let me write this in a little bit clearer way. So the right minus the left is just y squared over 4, and then the height's going to be, because it's a square, the same as the base. So my volume is just going to be, there's no pi because nothing is being revolved. This is the one where like the shapes are coming up out of the page or shooting up off of the base. And this is going to be the same base multiplied by itself. It's going to be y squared over 4 parentheses squared. With respect to y, lower limit again is going to be 0. Upper limit, the same as part B, because it's with respect to y. Upper limit is going to be 6. And I think it was just asking for the setup, so this is what the integral would be set up with. For part A on number 2, you got to find the area of the region. So you had to find a nice window to make this fit. So y is equal to 2 goes across like that. And this curve looks something like that. And where they intersect, where 20 is equal to 1 plus x squared, that's going to equal to 2. It's going to be at x equal to negative 3 and x equal to positive 3. So that gets us the limits of integration where they intersect. You're looking for the area of this region. So for part A, you're looking at just the integral from negative 3 to 3. The top region is going to be 20 over 1 plus x squared. The bottom region in this case is just going to be 2. It's with respect to x. And your answer on your calculator is going to be 37.963 for part A. Part B is asking to find the volume when it's revolved about the x-axis. So again, if I redraw my region, like something like that. You draw your sample rectangle from where you're revolving. So I'm revolving around the x-axis. That's going all the way to the edge. So this is the shaded part. You notice there's an empty space, so it's going to be a washer. It's going around the x-axis, so it's going to be with respect to x. So the top has a curve, and it has a flat bottom, a straight middle. This is y is equal to 2. This is 20 over 1 plus x squared, and this is just a line 0. Let me write this a little bit neater. This is the shaded part. All this is the entire, and this down over here is the empty. The entire in this case is going to be 20 over 1 plus x squared minus 0. So the volume is going to be the integral of 20 over 1 plus x squared squared. The empty is just going to be 2 minus 0. So it's just basically going to be minus 2 squared. All of that is with respect to x. The lower limit is the same as part A, which is going to be negative 3. And then positive 3 for your limits. And then you just punch this up on your calculator. And the volume is going to be 595.618 times pi. For part C, it's saying that there's some vertical line, x is equal to k, in the first quadrant that makes the area equal to 10. So if you think of this in the first quadrant, and here's y is equal to 2. Somewhere along here there's going to be a vertical line, let's say somewhere like, let's say right here, x is equal to k, such that this region is going to be equal to 10. So the integral of this would be, well, it starts at the x-axis, and it's going to integrate all the way until you get to k. So the vertical line k is where you're stopping your integrations, so that's going to be your upper limit. And then in this region you still have the top minus the bottom. You still have 20 over 1 plus x squared minus the bottom, which is 2. And you want this integral to equal 10, so you just set it equal to 10. And that's the setup. So if there would be a way to solve this integral, you'd be able to find k. You can find the value such that this little area equals exactly 10. And this is the setup that would get you that. And those are the solutions.